Good morning. Thank you for showing up. I'm going to jump right into this as much as I can, because as you know, we've got a very short time frame, and we've got a lot to cover with this. Now, when I first came up with this presentation, it was specifically designed for property managers, but we also assumed that we'd have facility managers, consultants, engineers. And I guess my first question is, how many of you guys are property managers? Facility managers? Consultants and engineers? So it's about okay. Because of the time constraints, and I'm jumping ahead a little bit, I'm going to be trying to get two main points across to you during this. The one being that we're reducing ventilation in our office towers to try and save energy, and there's good reasons for trying to do that, but there's problems people haven't been taking into account with that. But we're also going to talk a little bit about CO2, because you can't talk about energy in 2015 in Canada without talking about CO2 and monitoring that. There's some technical stuff on the CO2 side that I'm going to try to gloss over a little bit, but if anybody wants to talk more about that, just because of time constraints, I'm going to be here in our booth until about 1:30 this afternoon, and believe me, I love to chat about this stuff. So, let's get started. Just in case you're curious, that's me, younger a little bit. This presentation is really the result of three of us working together. Dr. John Dean is the guy who founded CSPLUS, figuring this stuff out. And Fodio is an MIT aeronautical engineer, of all things, and a Stanford MBA, and he does the quantitative modeling for us. And a lot of the stuff on the technical side comes out of his modeling. So what's the point of this? I was at Buildex out in Edmonton a couple of years ago, attending a talk on retrofitting and energy savings. And if you don't know, Buildex, by the way, is put on by the same people as this is. And a very smart engineer was telling the crowd that I was in that one of the great ways to save energy was to reduce the fans, reduce the ventilation of the building to 17 CFM per the new ASHRAE standard. And I just about went into orbit thinking, what are you doing? And started researching this and found out that this is happening a lot. And it's flying in the face of a lot of interesting new science. So what's happening? Why is this going on? If you're a property manager, if you're a consultant, you know this. You're enormously under pressure to reduce energy. I mean, it's getting hammered into you every day. We know this. And the economics of it are there, but the environmental stewardship is coming from, the LEED, the BOMI best, and now you're starting to see governmental pressure. The reporting stuff is going to eventually probably start turning into requirements. So be aware of what's coming down on you and be ready to push back if you have to. So why is this a problem? Well, 20% of commercial building energy use in the USA, and we assume in Canada as well, 20% of the energy use is from commercial buildings. That's a big chunk. 40% of that energy is strictly for your HVAC. And I'll do the arithmetic for you in advance. That means that 8% of the energy we're using is for HVAC in commercial buildings. That's a staggering number. It also translates into 5% of greenhouse gases. So it's not a small problem. There's good reasons to be saving energy. Nobody's disputing this. But as a result of this, in 2010, ASHRAE reduced the standard to 17 CFM from 20 CFM per occupant for fresh air ventilation coming into the building. The accrediting bodies, and I'm talking in particular about LEED, BOMI best, and now UL is getting into the picture, are all targeting energy savings at the cost of ventilation. But what we found is that the standard ASHRAE, 62.1 is the magic book, we're finding very poorly understood by a lot of the people who are referencing it. And of course, you've all been to the BIM sessions and what have you, the building automation. The buildings are getting really, really smart and maybe just a little too smart. So what's been going on in the meanwhile? We've got major health studies going on out of Harvard Public Health, out of the US EPA, out of Lawrence Berkeley Laboratories, showing the significant health effects of reduced ventilation. And I'm talking about at any level. The other side of this that I want you to remember is, even if you think you're getting good ventilation at whatever level, you may not be getting what you think you are. This stuff is trickier than people realize, and some of it is really counterintuitive. So be careful about claims that are being made by people trying to sell you stuff. So this is your takeaway. Lowering people's fresh air in your buildings to help produce energy is a bad idea. It doesn't make economic sense, and we'll cover that in some detail. It's poor environmental stewardship, and it's poor public policy. If that, I'm not trying to be contentious or anything, but that's usually where somebody goes, what? Okay, so what am I talking about? How much ventilation are we talking about? Well, everything comes back to ASHRAE and ASTM. These two organizations and the documents that they issue actually cross-reference each other. But every BOMA BEST, the governmental services, the provincial services, LEED, Underwriters Laboratories, they all reference back to ASHRAE 62.1. So that makes life a little simpler, because if push comes to shove, you can always pull out a copy of ASHRAE 62.1, wait for your eyes to bleed when you try to read it. But it's a very specific document, and it's actually very well written. It's just very, very dense. In Alberta, just to point out how bad things can be, the Public Health, Alberta Health Services actually issued a document that says 5 CFM per occupant in an office tower. That is a flat error on their part, misreading the ASHRAE standard. They probably mean 17 CFM per occupant. In Ontario, the last thing I could find was from 2005, and they're talking about 1,000 ppm of CO2, which works out, at the time they wrote it, that was about 17 CFM per occupant. It's now about 18 CFM per occupant because of rising CO2 levels. It's kind of one of those things. If you're going to derive this stuff from CO2, you've got to keep tracking this stuff. The new BOMA BEST is coming out, and they make specific reference in different places to CO2, but basically they're saying less than 450 parts per million above ambient, which works out to about 24.3 CFM per occupant. Okay. The references to it, depending on where you look, are either to ASHRAE 62.1, the 2004 version, or the 2007 version, or they don't make reference to any year at all. So you get to pick and choose. It's pretty confusing. But the really dangerous point for me is that it punishes energy use, right? If you use more energy, you lose points. And if you use energy to have more fresh air, they don't compensate you for that. The new version LEED coming out, version 4, they also reference 62.1. It's not clear which version, at least. I've seen specific version references, but it seems to drift all over the place. But this is good news. The newest version says that you get bonus point, I think 1 bonus point, if you're 30% above the minimum. It's good news because it's good that they're acknowledging it's a problem. It's bad news because I don't know where they got 30% from. It's just a magic number, as far as I can see. And when you actually take a look at the studies that we're going to take a look at in a few minutes, it should become obvious that there is no magic number here. It's essentially the more the better. It's not clear to me going through LEED version 4 whether they're talking about 17 or 20 CFM per occupant as the minimum standard. Is anybody in here a LEED certified person? Do you happen to know that off the top of your head? If they're specifying? Yeah. I've got the documents, I've gone through them, I can't figure it out. And it still punishes energy. So you get a point for more ventilation, but you don't get a compensating energy credit to get that ventilation to the people. Underwriters Laboratories, I don't know if everybody knows who they are, they've just got into the game. And they have an IAQ standard that they're issuing and they're applying. They just issued their first one in Abu Dhabi, of all places. I was talking to their chief scientist actually last week and asked him about this. And they reference 62.1, and it's assumed to be the current version. They're not big fans of much more ventilation, although they agree that the ASHRAE minimum is not optional. That second point, by the way, notice is unofficial. Their published document just says meet ASHRAE. So, what does this document ASHRAE really say? I'm going to talk about offices, but it varies depending on your what workplace you're talking about, but we primarily work with skyscrapers, and I'm assuming a lot of the people in here are office space. 17 CFM per occupant is the minimum, and this is the point I just can't emphasize enough, and ASHRAE makes it very clear themselves, and we'll go into that a bit. But the parallel I have is, I had a neighbor who would get up at 7 a.m. on Saturday morning and get his leaf blower going to clear the snow off his block. That's legal. It doesn't make you a good neighbor, right? That's a minimum standard. It's based on 4 out of 5 people not being immediately offended when they step into your office space. Think about that for a second. And they don't call it out in the latest version like they did in the previous versions, but the standard was not developed through some great science. It was developed based on human effluence, so that 4 out of 5 people coming into your space don't smell your workers. Stop and think about that for a second. The ASHRAE standard says that 1 out of 5 people coming into your office are offended by the smell of your workplace. That's the acceptable minimum standard. I don't know about you, but I don't think that's an acceptable minimum standard in a modern office tower. Not even close. I don't like just reading walls of text like that, but that's it. That's a direct quote out of ASHRAE. 15 seconds, ick. I promise this is only the second wall of text I'll give you today. The other thing to bear in mind is a lot of people think I'm attacking ASHRAE when I do this. I'm not. The people who write ASHRAE stuff are very smart and they know exactly what they're saying. They know the limitations of their claims. They say right in that it's a subjective evaluation method, testing odor and sensory responses. That's it. They point out specifically carbon monoxide and radon are 2 examples of odorless contaminants, significant health risks that they will not capture with this by their standard. And not to mention microbiology, volatile organic compounds, you name it, they're not concerned with it in this sense as far as ventilation rates. By the way, they've got plenty of good stuff with respect to these other compounds. But when somebody starts pointing at ASHRAE as 17 CFM as a standard, you need to be able to go, hold it, that might not be something that we're really comfortable with. Okay, so that was a lot in a hurry. Quick chance for any questions? Okay, I can go on. Okay, it's detour time. There's going to be formulas. You don't have to know these formulas, I promise. You can't talk about ventilation without talking about CO2 nowadays. It's just too important. So there's a big confusion right off the bat. Are we talking about it as a contaminant in the space or as a proxy for fresh air? Normally, like 2 years ago, we'd be saying, don't worry about it as a contaminant. At the levels we measure it in office towers, we're not concerned about it. Not so true anymore. But the main reason we measure it is because we want to use it to determine your ventilation rate. And it's really that simple. CO2 levels, when measured properly, can help us tell if you're getting proper ventilation, but you got to be really, really careful about false confidence on this stuff. This is very squishy stuff. We issue everybody has nice scientific looking reports, including us, but there's a lot of interpretation and squishiness around this. That, by the way, is a technical term, squishiness. So as a contaminant, notice the tired looking people in the audience. Natural background levels of CO2 in Toronto 2015, about 390 parts per million. We're pushing 400 soon. Typical office tower, 750 to 1100. The health recommendations, Ontario is 5,000 ppm, Health Canada is 3,500 ppm. So you can see we're not getting anywhere near those limits. So we're not terribly concerned about that. And again, you don't need to understand this chart other than a very quick thought to go, you've got white, blue, and black little indicators. They represent really good fresh air. About the ASHRAE standard is the blue one, and the black one is about 2,500, which, by the way, is the ASHRAE standard for a public auditorium like we're in right now. Again, I know you can't read that. It's not that critical. What happened, though, is that this is better, this is worse. So superior capacity, dysfunctional capacity of typical tasks that a knowledge worker would be doing in an office tower. And what you can see is that things like basic activities, initiative, information search, breadth of approach, strategy, if you're at these high levels, 2,500 ppm, you're becoming dysfunctional. And that means that if you're in an auditorium like this and it's full, you're going to be affected. But even at the ASHRAE standard, you can see measurable cognitive effects. So that's not exceeding it. That's at the ASHRAE standard. You can see that effect. Now I have one caveat for this. This is a fairly new study, and it's being confirmed. I mean, I think it's probably true, but I would caution it's one study, so we don't want to get too crazy on it. So what is ASHRAE talking about? Well, they're saying 17 CFM, which is about 1,034. In schools, and I have to divert to this just for a brief moment, they're accepting in a lecture hall 8 CFM per occupant, which is about 1,758 ppm. Just a quick aside, imagine if you remember writing final exams in a big packed auditorium and wondered why you couldn't think. Now you know why you couldn't think. This stuff is scary stuff. It looks like maybe we didn't understand this stuff as well as we thought we did. Now I did warn you, there's a formula. There's a mass balance equation as how we derive this, and it's a really simple formula to derive it. We're essentially looking at how much CO2 we generate per person, and we got a pretty good idea what an office worker is going to generate. The CO2 inside versus the CO2 outside gives us that number. And the only real variable there is if somebody's a different type of worker, if they're more active or less active. The catch is that the key phrase there was what's called the steady state. And the problem with the steady state is the only way that you know that you've reached a steady state, if you're charting it out, is that you've hit a plateau. So the fact that you get a number, it might, if it's a high number, you know it's bad. If it's a low number, you don't know it's good. And this is very counterintuitive for a lot of people. I've got a couple of diagrams we're about to see that I hope point this out. But even ASTM, who came up with this stuff, they can be used to confirm inadequacy of ventilation, but not necessarily its adequacy. So if somebody's got ventilation and they're going in and doing a CO2 test and they come back and they go, oh, it's great. It's 700 ppm, we're fine. You don't know. You just don't know. If they come back and say it's 2,500, you know it's bad. If they come back and say it's 700, might be good, might be bad. We don't know. And somebody who says they do know needs to be challenged on that. This chart, this is actually from a Calgary office tower, but it would apply just as well. This is about as good a chart as you're going to see of CO2. The shaded areas represent working hours. You can see people coming in the morning, the fan's getting turned on, and then the CO2 climbs and then kind of plateaus. And you can see there's a nice steady state. See the plateau? Now I'm saying this is as good as you're going to see. Those plateaus are not exactly flat lines, are they? So I'm pretty confident, though, I can interpret this chart. This is good ventilation in this space. What do you think about that chart? Doesn't look terrible, right? I mean, it's peaking a little high, but the point I want to make is, where's the plateau? Kind of, maybe, sort of. And what's going on here? That it's not even getting down to ambient level. What's going on here, I can tell you, is you've got a building where the tenants have brought in way more people than they're supposed to onto that floor, and the system can't handle it. This is not a criticism of the building, by the way. This is a criticism of the tenant. I will tell you, if anybody's curious what was happening here, this is an accounting firm, and you'll notice the time frame, February, tax time. So they're literally just overloading it. But because they didn't tell the building owner, they're basically creating a very unpleasant, inefficient working environment for themselves. That building, I happen to know, has a capacity of they could turn the fans up if they wanted, but they got to be asked. And this is my favorite. Any thoughts on this one? Looks like a heartbeat, doesn't it? So this is a real one, by the way. It's from 2014. I remember we got this in and I was taking a look at it for the client and thinking, I don't understand. I've never seen a chart like this before. What they had done is they've actually converted this floor into a fitness center. So what's going on is they come in the morning, yeah. So how much fresh air ventilation are they getting at noon? I have no idea. I mean, that is not a plateau, folks, right? I mean, it's pretty obvious. We're just speculating but they're probably not getting sufficient ventilation. It's a pretty safe bet. By the way, the formula is also screwed up because it's based on office workers' metabolic rates. These people are on spin cycles, going nuts. So it's actually going to be artificial. It's actually wrong both ways. So when somebody says, how's the ventilation based on this? I don't know. I can find out, but that chart can't tell me, right? We haven't reached a steady state. We don't know. You're going to hear me say a lot of this we don't know part. So, anybody in here heard of demand ventilation CO2? It's very popular. A lot of big companies are trying to sell it. It intuitively makes sense. It's great because you go, hey, we come in, we have a set point of make some number up, call it 700 ppm, and when we hit 600 ppm, the fans come on. And as long as we never go over 700 ppm, we know we're good, right? Maybe not. So be very careful. It's very powerful stuff. It's very intuitive to go, of course, if we never go over the bad number, we're good. You don't know that. Same as if you're going out and testing or having a consultant test and they just go in and start taking CO2 measurements. You take a CO2 measurement on this floor at 10 a.m., what does that tell you? It tells you nothing. So, these are my cautionaries for you. So your takeaway on this stuff, demand ventilation. It's dependent on steady state equilibrium, and I can tell you the people who are selling this stuff for the automation are not taking this into account. I really thought they were initially, but they're not. That simple on-off CO2 level stuff, you're going to get false confidence. You're going to think you're ventilating properly, and you may be, but you don't know. It's fantastic, by the way, for a space like this. It gets occasional use, as long as it's a simple on-off, right? You just want to know if people are in the room, put the fans to max, you're good to go. It is explicitly not recommended for constantly occupied spaces like offices or schools. And the people who invented this stuff will tell you that. They'll pound on their podiums trying to get this across, but somehow the message isn't making it out. Breather? That's different. So, back to ventilation. That was your whole CO2 side trip, by the way. You don't have to remember all of that. The main thing I want you to remember is be very skeptical about CO2 ventilation claims, unless you're very confident that you know what you're talking about and the people you're talking to know what they're talking about. So, why is more ventilation better? This is one of my favorites. Most of the contaminants you're worried about with indoor air quality are from the inside of the building, believe it or not. So the more fresh air we bring in, the more we dilute. And that doesn't mean we shouldn't be trying to reduce the things we're polluting inside with, but more fresh air, it's great. We normally filter our buildings with pretty efficient filters. And it removes outside dust, which means it also removes pollens, and it reduces those ride-alongs like fungi, the microbiologicals, viruses, bacteria. This is another counterintuitive point, and I want you to think about this for a second because I get this objection all the time. If you double the ventilation in a space, you're not doubling the contaminants from outside typically. I'll talk about that in a second. At this point, I've had a lot of people object and say, look, if it's really dusty outside, we don't want to turn the fans on. But if you've got MERV 12 fans running, you double the ventilation, and let's say there's a million particles per square foot outside, and you're getting a 90% filter efficiency, which is not unusual. The more you ventilate, remember, you're just moving the air through. The more you ventilate, the less dust you're going to have inside. But even for something that's not being filtered, let's say you've got 100 ppm of some mystery contaminant outside, doubling the ventilation doesn't make it 200 ppm inside. Remember, it's a flow-through system. So it's still going to be 100 ppm inside if it's 100 ppm outside. In general, there's some edge cases here. So when somebody says, if it's dirty outside, we don't want to turn the fans up, that's typically not the correct response. Typically. There's always an exception to the rule. And now comes the kicker, because all of this stuff so far has been about human health and understanding it, but let's talk about money, because that's where people actually start making decisions. Here's a claim for you. It costs way more in lost productivity than can be saved in the cost savings of saving energy for your ventilation. How much more? Direct costs of sick days 6 to 9 times. Not in lost productivity of sick people working, not in lost productivity of people just not being effective. Actual people staying home, calling in sick. And this is hard data. The indirect costs are probably much greater than that. But let's just focus on sick days, because I think this is an argument anybody can understand. A couple of major studies done, I alluded to earlier. Milton did the Harvard study, believe it or not, back in 2000. And Mandel has been doing a lot of work. He just did a major study in the US schools. But look at this. About 0.06 sick days per CFM per occupant, about 0.05 sick days per CFM per occupant, depending on who you talk to, different environments. So it's still apples to apples. That number doesn't look that big. And by the way, there's a chart indicating, that's our own model. There's the schools, there's the Harvard study. By the way, we spent a lot of money coming up with this great quantitative model because we were going to go out and sell this product to our property management clients, explaining how they could figure out exactly the right ventilation. Save your money. It's basically a straight line. The more ventilation you provide, the healthier your people are. It's just that simple. We did a quick breakdown on our model. This is not a scientific study. This is somewhat beyond informed speculation, but not what we would consider publishable, but just for your own sense. This is what our model indicates is causing the problems. So for all the excitement about molds, notice what's going on here. So, think for a second about a modern Toronto office tower. 50 stories, 1 million square feet, not unusual. Say 5,000 people, a little dense, but not crazy, right? And currently, saving energy by providing the ASHRAE minimum standard of 17 CFM per occupant. And I think you know that there are Toronto office towers of that scope doing exactly that today. And proud of it, rightly so, because that took some work. So what happens if we increase the ventilation from 17 to 32? I just pick 15 as an example. Well, if you've got 5,000 occupants, times 15 CFM per occupant, we estimate that's about $5 per CFM per occupant per year. Now that's going to vary a lot with the energy prices going all over the place, but that's not a crazy number, right? It's within, it's a reasonable number. About $375,000 when we did this. It's probably now quite a bit less because of the energy crash. Not a huge amount, but somewhat. So, remember 5,000 occupants by this small amount of 0.06 days per CFM per occupant per year, times 15 CFM per occupant, 4,500 sick days reduced in that building. That's a staggering number. And if you assume $100,000 annual salary plus benefits, which let me tell you is pretty modest for a downtown Toronto AAA office tower, 220 work days a year, 4,500 sick days, $2.3 million in lost sick days versus $375,000 in cost. I don't understand. I do understand, but this is pretty compelling stuff. And I was expecting to, this is about the 4th or 5th time I've given a variation of this presentation, and nobody's given me any pushback on these numbers. So, taking that into account, I'm going to stick with my numbers for now, but so this is the problem in policy. My claim, reducing people's ventilation for energy savings is bad environment and public policy. I think we've established it's bad economics. Trading human health for energy gains is not a good environmental choice as a general rule. That's not especially contentious. What we'd like to see starting to happen is that those significant funds that are being saved be used for other environmental initiatives. This is not the place to be trying to save the money. So, back to my favorite guy here. You have to be older to recognize this, by the way, but usually by now somebody's going, so how much ventilation should we be giving? Well, you get a choice. You turn it up until people complain or you hit your system capacity is the short version. If you remember those charts I was showing you, those curves, it's pretty much a straight line. And so the more ventilation you can provide without creating problems, the better off you're going to be and the more money you're going to save and the more productive your building and workplace is going to be. Don't worry, if you've got an older building, it'll have the capacity. People will complain long before you reach that capacity. Newer buildings, it's trickier. They're now I hate to say it, but they're engineering and architecting sick buildings again because they're building them without the capacity to turn the ventilation up. Basically looking at ASHRAE going, we'll engineer this for 20, 25 CFM max. And once you've built the building, trying to retrofit is brutal. So, after spending all this time telling you to turn your fans up as much as you can, now I got to tell you when you might not want to do that, because there are always special cases. One of the ones that we run into out west a lot, we get forest fires. And it might be the case that you want to think about if there's a short-term episode or if there's an emergency of some kind, you might not want to just be bringing in those hazardous materials or all that smoke for a very short time frame. Overall, yes, but you might want to reduce it for a day or so, depending on the circumstances. Very special case. Ironically, ozone, because it's such a nasty reactive thing, is typically lower inside your buildings than it is outside because it's so reactive. The other pollutants in your building react to it, and so you get lower levels. So it's one of the very rare cases where you could actually be increasing your ozone levels by increasing your ventilation. We don't really think that's a significant problem, but you should be aware of it. If you have really high ozone levels outside, I'd almost say you'd have to take this on a case-by-case basis and measure what effect it was having. And the other one that people don't think about is things like radon and VOCs, volatile organic compounds that are infiltrating your building, usually out of your lower levels. This is one of my favorite charts. This is a radon gas chart from 2014, about a year ago actually. And I don't know if you can see what's going on, but again, the shaded area is your occupied hours. And what's going on? You're coming into the weekend, this is not terrible radon levels. And they turn the fans on. What's going on? They drop down again. Fans come on. Whoa. So what you've got basically is the radon is gathering. They come in at the start of the workday, the fans come on, and they suck all the radon out of the ground into the building. This is a bad idea in general. And by the way, that radon reading, although it's a short-term radon reading, would be interpreted as being fine by current standards. If these were much higher, and they certainly could be, you can't draw too much conclusion from a 1-week sample for a radon sample. This building could have significant problems with radon. And you could see exactly the same effect. We didn't measure the VOCs in this building yet, but you should expect to see the same sorts of behaviors if they had a VOC problem from contaminants in the soil coming in. Make sense? Okay, so what now? Again, I'm targeting this more to property managers, but it also works for facility managers, the opposite side of the same coin. But the first thing I'm saying is, if you believe this and you want to act on it, get tenant buy-in. Share this information with them. Ask them to pay for your increased ventilation costs. They should be happy to, seriously. If they understand this, why would they not want more fresh air ventilation for a nominal cost? It pays itself back instantly. I mean, literally instantly. It can be used as a marketing differentiator if you're a property manager to have a healthier building and make a point of that. And, start pushing back on BOMA and LEED, frankly, and the governmental organizations that are trying to make, to focus on this. The other thing is, if you're having major renovations or new construction, insist on higher capacity. Even if you don't use it, if you don't build in that capacity, you're never going to be able to get it back. I have another slide that I took out of this just because of the time constraints, but if you're a facility manager talking to a property manager, please be willing to pay them to do this, right? So here's your takeaway. Again, lowering people's fresh air ventilation to help reduce energy is a very bad idea. And please be very skeptical about CO2-driven claims regarding fresh air ventilation, unless they're very well understood. And that is that.